Hi there, and welcome to the Air Equipment YouTube channel. This is our fourth and final segment on the topic of energy recovery ventilators. Besides having a terrific product line, Renew Air, the manufacturer we represent here in Connecticut and Western Mass, also offers a really impressive design tool called their ERV calculator. This is a web-based program that allows you to crunch the numbers and figure out exactly how much energy is being saved. Here's an image of the Renew Air website, and by the way, that would be renewair.com, RENEWAIRE, don't forget the E.com. So renewair.com, and if you click on the link that's circled here in red, the ERV calculator, you activate the program. And it's very, very simple. When you create a project, all you need to do is there's a pull-down menu where you can import ASHRAE weather data for the location of your project. In this case, I've selected Connecticut, and in Connecticut we have two options, Hartford and Bridgeport. So it imports the weather data right into the program, and then you come to an input screen where you have to put in the CFM and external static pressure for each of the two airstreams, the exhaust airstream and then the supply airstream, the fresh air coming into the building. You pick the model. Now, to pick the right model, you can do that either off information on the website or from the catalog, or feel free to give us a call at Air Equipment and we could walk you through that. So you pick the right model. In this particular case, for this 1800 CFM of airflow, the model HE3X-I8INH, it's in the middle of the left-hand column is where the model is selected. And then the lower part of the page here, this input screen, you can see that there is the ASHRAE data for the design days for winter and summer are there. And then you put in your room conditions. What's your temperature and humidity in the space during the two seasons, winter and summer? Very typically for a commercial building, we'll use 75 degrees and 50% RH for your summer air conditioning target, and in the winter it's 70 or sometimes 72 and 35% RH. And of course this is very important because the temperature that's in the room, that is the energy that we're going to recover. When your exhaust airstream leaves the building, we grab that energy that you've already paid for and transfer it to the supply air coming in from the outside. So it's very important to know what the temperatures are in the space during the two seasons, and to have the ASHRAE data for the outdoor temperatures. Now, any one of these variables can be overwritten. If you want to use a little bit colder than ASHRAE, just to be safe, you can plug in whatever numbers you prefer. So we enter the data on this screen, and then the calculator program runs the performance. And as you can see on this page, and I've highlighted some of the key pieces of data in red, in the very center of the screen, we see that the outdoor temperature on a design day in the winter is 2 degrees above zero, but that air, having the energy transferred from the exhaust airstream to the supply airstream, that air has now gone from 2 degrees up to 52.3. So we have raised the temperature over 50 degrees without spending any money, without having to burn more oil or more gas. We've just transferred the energy that already existed in the building to the outdoor airstream. Now in the summer, when a design day is 91 dry bulb, 73 wet bulb, that air has been reduced down to 79.2 dry bulb and 67 wet bulb. In other words, we've made it a lot cooler and drier just by transferring energy from the exhaust airstream to that outdoor air, the intake airstream. So this tells you exactly what our new supply temperatures are going to be. And as you can see, we're certainly, it's going to take a lot less money, a lot less electricity or natural gas to condition that air once we've already raised the temperature in the winter or lowered it in the summer. The very bottom right of the screen here shows exactly how much energy we've saved. In the winter, it would have taken 176,000 BTUs to properly heat up that outdoor air. Now it only takes 53,000 BTUs. So we've saved over 70% on the heating bill. In the summer, it would normally require 5.5 tons of cooling to properly condition that outdoor air. Now it only requires 2.2 tons. So we have saved 3.3 tons of cooling, or 40,000 BTUs, and we've reduced the electric bill significantly. So this page right here tells you some really hard and firm data, so you know exactly how much energy is being saved. At the very, towards the top of the screen here, we see the actual recovery effectiveness percentages. In both winter and summer, our sensible recovery is 74%, and the total, when you factor in sensible and latent, in the winter we are saving 70% energy, and in the summer 60%. And anything over 50% is really terrific. The final feature of the online energy recovery calculator is a payback calculator. Now with this, we have to input some additional variables. We sometimes have to make some assumptions, but in order to run the payback calculator, we have to estimate how much it would cost to install the ERV system. We need to know what the going rate is for electricity or natural gas. We need to estimate how many hours per week the unit will be running, and also we have to subtract out any cost that might have been required to install exhaust fans, because now we're using the ERV, the exhaust side blower, as our exhaust fan, so we're saving some money there. And you plug it in, you run the numbers, and in this particular case, the payback period is 2.5 years. So in 2.5 years, that investment, the amount of money required to install the ERV into the system, gets paid back by the energy savings, and then for every month after that, it's just a bonus. The owner of the building is saving money. So in this case, obviously, it's a really wise decision to go with the ERV. In our experience over the years, we've seen payback periods anywhere from 1.5 years up to about 7 years, and pretty much anything less than 8 or 10 years is worth doing. Typically with the ERV, it pays for itself a lot quicker than that. 2.5, 3, 4 years is pretty common. So this online calculator gives us some powerful tools to work with, where we can, instead of just saying in a very generic way, yes, let's put ERV on the project and we'll save some money. Now we're putting hard numbers on it, where we can tell the architect or the owner of the building, this is how much BTUs and tons of cooling we're going to save. This is how many years it's going to take to pay for itself, and it becomes a much easier decision to make. So this is the end of our fourth and final segment here. I really thank you for watching our YouTube videos. If you have any questions at all about ERV, about the Renew Air product line, if you need a selection, data sheet, a performance run, or even a pricing, feel free to give us a call. Air Equipment in East Hartford, our number is 860-290-6969. Thank you very much for watching, and have a great day.